Am I clearly audible? Is there any
Yes, ma'am.
disturbances? Okay. As I said, we are discussing about sequential statements, which we are using in a behavioral modeling. Okay. So, earlier we discussed about if statement, then case statement. So, now in continuation with that, we are going to discuss today. So, first of all, now we will discuss about null statement. Okay. Now, what is null statement? It states that there is no any action that will occur. Okay, when this statement is executed, there will not be any action in a VHDL after this execution of null statement. So, this uh, system will ignore whatever is the null statement and then it will proceed to the next statement. Okay, so this statement is usually used to explicitly state that no action is to be performed when condition is true. Okay, that means uh, earlier which condition we are considering this if that condition is true and if it is the that condition is followed by null statement, then if that condition is true, there will not be any action performed. Okay. So this null statement where it is used, okay, it can be useful in a case statement where all choices must be covered. Okay. Now, as we know that when we considered about case statement, that all choices that should be considered when we are stating case statement. So in that case, if we don't want to perform any action after certain conditions or certain choices, then in that case, we can use null statement. Okay. So the in a case statement where all the choices that must be covered, uh, but out of that some can be ignored. In that case, we can use null statement. Okay. So syntax for this null statement is just simply write null and semicolon. Okay. That means what will happen? Simulator or the system will ignore this statement and then it will proceed further. Okay. Now here one example is given for this. So we have declared two variables, variable A and B, which are integers. Okay, which having the range from 0 to 31. So we have the statement variable A comma B colon integer range 0 to 31 semicolon. Okay, now we are using a case statement. Okay, now that means here as the range of A that is from 0 to 31, so A can have any value in between 0 to 31. So we have the case statement. So we are using case A. That means we are considering the values of case of the variable A. Okay, so the case A is when this value of A is in between 0 to 12, then we are going to assign whatever is the value of A to B. Okay, so that means B will have value of A. And when other case is there, that means when A is having value greater than 12 up to 31, in that case, there will not be any action that is performed, and that is why there is a null condition that is used, null statement that is used, and then end of case. Okay, so that means what will happen in this case? Whenever A, there is a value of A is in between 0 to 12, B will have the same value as that of A. Okay, but in other cases, uh, there will not be any action that will be performed. That means B will have whatever earlier value, the same value that will have. Okay, so this is about the null statement. Okay, that means there will not be any action that will be performed if null statement is present. Okay, so the next statement that is the assertion statement. Okay, now whenever we are doing a simulation, okay, that time if there is a certain error or warning is present, okay, that means if we are getting certain error, then it is convenient to output a message which states that there is a error or there is a warning. That means if you have seen in a C language also, whenever you are getting certain error, that time you or in case of warning, the message that comes on the your screen that there is a error or there is a warning. So in a what is it does if we are getting then we get the idea that there is certain error and we need to correct it. Okay. So the assert statement, this allows for testing a condition and issuing a message. Okay. So this assert statement, what it does, it allows a certain condition, and if it is false, then in that case, it issues a certain message. Okay. So the assert statement, it checks to determine if a specified condition is true, and then it displays a message if condition is false. Okay. The syntax for this assert is statement, that is assert then condition. Okay. So here you need to define what is the condition, then report, and then error message. Okay. Whatever error message that you want to display or that you want to print on your screen, that will be followed after report keyword. Okay. And then there is one more keyword that is used, that is a severity, and after that there is a severity expression and then semicolon. Okay. So now this condition, whatever condition that we are stating, that must be Boolean type. Okay. So that it will be in terms of true or false. Okay. Now if it is true, then there will not be any message. But if the condition is false, then it will print the message as per the whatever we are stating at the error message. Okay. The error message is a string type expression, and then the severity expression, it is a predefined type of severity level. Okay. So there are 4 levels of severity. One is the failure, another one that is a warning, then error and no. Okay. The severity level is used either to terminate a program, terminate a simulation run, or just to give a warning message and then continue. Okay. So depending on what is the severity, okay, whatever conditions we have stated, whether uh, simulation should be continued or it should be stopped at that condition. If the condition is failed, that will be decided by this severity level. Okay. So whether there is a failure or whether there is an error, then warning and note. These are the 4 levels of severity, and then depending on that, simulator will decide whether to terminate program or just give a warning message and then continue. Okay. So here this assert statement, that is useful for timing check, okay, or certain out of range condition. So in that cases, we can use this assert statement. So here we have one example for this is an assert, and then in the bracket there is a condition x is greater than 3. Okay. Then report in a double quote setup violation and then severity warning. Okay. Now what this will do, this whenever these statements is executed, that time simulator will check whether x is greater than 3 or not. If x is greater than 3, that means it will be true. But if it is less than 3, then that means the condition will be false, and in that case there will be message that will be printed, that is a setup violation. Okay. And then it will just give us, this is a warning. Okay. That means this is just a warning. The simulation will be continued ignoring this, and then here the level of severity, that is of a warning type, just a warning type. There will not be a discontinuation or program will run even after that. Okay. Now suppose we have one more example, that is suppose in a RS flip-flop, okay, if both the conditions, that means set as well as reset, both are 1, what happens? Yes, what happens in a RS flip-flop? Suppose both set as well as reset are at the 1 condition. We get the forbidden error, isn't it? So Now, in that case, that means whenever such a condition occurs, we want a message that is there is a error. So here we can have the expression that is a condition that asserts not s is and then s is equal to 1 and r is equal to 1. Okay. So here that means it will check whether both of these are 1 or not. Okay. So then if it is a not condition that is a fulfilled, that means if it is a true, then uh, it will not be, if this condition is true, then there will not be any report that will be generated. But if this condition is failed, that means if not of s is equal to 1 and r is equal to 1, that is not 0, that means that is not equal to 1, then in that case, uh, it will have the report that is both values of signals S and R, that is 1. Okay. And then severity of this is an error. That means now in this case, there will be simulation will be stopped because at that condition, there will be error generated. And so this here we can consider this is the severity, that is error. Now, in both these cases, we have certain conditions. Okay, but suppose we want to print a message without any condition. Okay, that means to unconditionally print out a message, we can use the condition that is false. Okay, so that means actually we don't have the condition for which we want to print a message. But in that case, we can use the condition that is false. So assert false, and then we can have report. Okay, so whatever statement that we want to print, that will be followed. That means error message that will be followed after this keyword report. And then we have here this message that is starting simulation. Okay, so here this is just now there is no any severity warning, severity statement that is given. So that means there the simulation will be continued. Okay, so there is no any warning or no any error type of severity that will be present. So just this execution of the statement that will be continued. Okay, so this is about the assertion statement. Okay, now the next two sequential statement, that is a loop statement. Now, can anybody tell me when loop statements are used? When loop statement is used?
मोर टाइम्स जर आपल्याला प्रोग्राम करायचा.
Okay, when we want to execute certain statements number of times or repeatedly we want to execute certain set of statements, then we use loop statement. Okay, which loop statement that or format that you have used earlier? कुठले कुठले वापरले तुम्ही loop?
For loop, while loop.
Okay, for loop and while loop. Okay, the same type of loops that are present in the VHDL languages. That means here also we can use for loop and while loop. Okay, so here syntax for this is a, suppose we are using a while loop, then there will be while and then there will be condition. Okay, now if we are using a for loop, then there will be loop specification, because when we are using while loop, that time we need to consider certain conditions. Till that condition is true, we execute that loop. Okay, and when we are executing for loop, we need to give certain specifications, and depending on that, that loop will get executed. Okay, after that there will be a keyword that is loop. Okay, and then this will be there will be sequential statement present in that loop. म्हणजे जी कुठली स्टेटमेंट आपल्याला एक्झिक्यूट करायची ती त्या कीवर्ड लूप नंतर येते. Okay, then there will be next state and as well as exit statement. Okay, now these are optional. Okay, so if we want to have this, then we can have, otherwise we can skip this. Okay, and then end of this loop. Okay, so it may be while loop or for loop. So we are going to discuss about these loops in detail again, but till then, so here, as we know that there are two different types of loop statements. One is the for loop and another one that is while loop. Now, these are also called as a iteration scheme. Now, you can also define a loop without the iteration scheme, which means repeated execution of the statement. However, in such a case, you have to use a wait statement and a exit statement. Okay, so that means if there is no any iteration scheme that is used, then in that case you need to wait till the certain condition that is to be fulfilled, and then you should have a exit statement there. Okay, so here we will have this first example, one example which is without an iteration scheme. That means there is no any for loop or while loop that is used in this statement, okay, or in this example. So there are two nested loops that are used, but remember that here we have not used any for or while loop. Okay, so if you look at this statement, okay, now what will happen in this? Can anybody tell how this program will execute? Just read out. Okay. So, who's going to tell? Can I take a name or what we have done here? We have defined one process and named it as a countdown. Okay. So there are variables that is a minimum, minute and second. Okay. So min and sec, that are two variables that are used, which are integers and having the range from 0 to 60. Okay. Then we are beginning with this process. So there we have used two loops. One is the L1, which is a loop, and L2, that is also loop. Now, here the one statement that is used, that is the exit L2 when sec is equal to 0. Okay. And then that means what will happen whenever sec is equal to 0, that time we are going out of this L2 loop. Okay. So now again there is a one statement that is used, wait until clock apostrophe event. Okay. So that means here attribute type that is used. So there is a change in the clock level, then we have to wait, and also at the clock is equal to 1. That means when clock is going to become 1, and there is a change in the clock event. That means if it is going from 0 to 1. Okay. So clock apostrophe event, that means we are looking for whether there is a change in the level of this clock. Okay. Then what we are going to perform? We are going to have sec is equal to sec minus 1. Okay. So this loop will get continued till sec is equal to 0. That means we are going to exit out of this only when sec is equal to 0. Okay. And then end loop L2. So when sec is equal to 0, we are going to end loop L2. Then we have the another statement, that is exit L1 when min is equal to 0. Okay. Now again we are going to have min is equal to min minus 1. Okay. Now if we are doing like this, then we are going to assign sec as the value 60. Okay. म्हणजे सेकंड काय होतील, मिनिट्स आपण 1 ने कमी केलं म्हणजे सेकंड आपण 60 ने वाढवणार आहे. सो 6 इज इक्वल टू 60 अँड देन एंड लूप L1. आता लूप L1 कधी एंड होणार आहे? ज्यावेळेस मीन इज इक्वल टू 0, कारण तेव्हा आपण ह्या L1 या लूप मधनं एक्झिट होणार आहे. अँड देन end of this process. Okay, so that means here we have not used any iteration type of skip, but we have used two loops. Okay, and then these are the nested loops that we have used. So this is one example of having loop statement. Okay. Uh, Now we will discuss about the for loop. Okay. Now see the difference between how we are when we are going for the loop for loop statement. Then you can get that there will be minimization of this statements. Okay. So a for loop, it is a sequential statement in a process. Okay. So we are using for loop in a process that iterates over a number of values. So for number of values, we are using this for loop. Okay. So that the loop index does not have to be declared. So here the one is that we need, there is no need to declare a loop index, but um, and it can be reassigned a value within a loop. So it is a by default integer. The value of this loop index that can be read inside the loop and it is not available outside the loop. Okay, so remember that this value of loop index that is available inside the loop only. It is not available outside the loop. And one cannot assign or change the value of this index. So here, if we look at the example of this loop statement, then we can have for. Okay, so here suppose we want to iterate this for 10 times. Okay, so then we are having the value of I from 1 to 10. Then we can have the loop, this for loop as a for I in 1 to 10. That means here we are specifying the range of this loop, then loop, then A of I that is equal to I into I. Okay, and then end loop. So what this going to calculate? It is calculate A of I, which is equal to I into I. Okay, so this loop will be iterated how many times? किती वेळेला हे loop iterate होईल?
10 times.
Yes, it will be iterated 10 times. Okay, and when I ची value 10 होईल त्यावेळेस काय होईल? ते end होईल. Okay, so that means each time it will be calculate the values of this A of I. Okay, then another you can have a loop that is a for I in a x down to y. Okay, so here range of this I that is x down to y loop, and then A of I that is calculated as a I into I, and then end of loop. Okay, so this is the for loop. Okay, so it is similar to that of how we are studying a for loop in a C language. Okay, it is nearly similar in that way. Okay, now the another type of loop statement, that is while statement. Okay, now this while statement that executes a loop body by first evaluating the condition. Okay, that means actually when we are studying a while loop, that time we are considering certain condition, and then this loop body will first evaluate that condition, and after that, if the condition is true, then only that loop is executed. Okay, otherwise it will not be executed, or it will, there will be end of that loop. Okay, so we have one example here. We have 4 variables actually. Suppose A, B, C, and D. All are the integers. Okay, so now we are defining one process. Okay, which has the variable A, comma B, comma C, D, which are integers, and then we are starting the process. Okay, so begin. Now here we have the condition that if A plus B is greater than C plus D, then we are going to calculate certain equations. Okay, Otherwise, if this condition is not fulfilled, then these sequence of these statements or these uh, equations that will not be executed, and then whenever this condition is first, there will be end of loop. Okay, so let us have these equations as a while a plus b is greater than c plus d, then loop a is a minus 1, c is c plus b, and b is equal to b minus d. Okay, and then end of loop, and then there may be certain another equation, and then after that there is a end of process. Okay, that means this is the while loop word. Okay, now how this going to perform, or how this loop will be iterated? जोपर्यंत तुमचं a प्लस बी हे ग्रेटर दॅन सी प्लस डी आहे तोपर्यंत जे काही फॉलोइंग इक्वेशन्स आहेत त्याच्यानंतरची ती एक्झिक्यूट होतील. नाउ लेट अस हॅव सर्टन एक्झाम्पल. ओके, सपोज a is having value 7. Okay, so you can write it down. Okay, and then b has the value 6, c has the value 1, and d has the value 2. Okay, are you getting this? Okay.
Yes, ma'am.
ओके, सो आपल्याकडे काय आहे, ए ची व्हॅल्यू 7 आहे, बी ची व्हॅल्यू 6 आहे, सी ची व्हॅल्यू 1 आहे आणि डी ची व्हॅल्यू 2 आहे. ठीक आहे, तो 7 प्लस 6 किती होणार, 13. ओके, सी प्लस बी दॅट इज 3. ओके, दॅट मीन्स ए प्लस बी that is greater than that of C plus D. Now this condition is fulfilled, it is true. Okay, so that means the next equation that will be iterated. Okay, so now we are going to calculate A, that is A minus 1. That means now A will have the value that is equal to 7 minus 1, so it will be 6. Okay, okay, now next will be C is equal to C plus D.
C is equal to 1.
C plus
1 plus 6.
C is 1 plus 6. That means it will
7.
have now new value.
7.
7. Yes.
7.
D is equal to B minus D. Now earlier value is a 6. D ची value 2 आहे. So 6 minus 2, that means D will have now value 4.
4.
Okay. Now, okay. So now A it has a value 6. Okay. As per this calculation. After this equations perform or it executed, त्याच्यानंतर A ची व्हॅल्यू 6 आहे आणि B ची व्हॅल्यू 4 आहे. म्हणजे A प्लस B किती होणार आहे,
10.
10. ओके, आता त्याच्यानंतर C प्लस D किती होणार,
C is 7 and D is 2. 9.
that is 9. Okay, so that means again A plus B is greater than C plus D. Okay, so again these equations will be iterated or executed. आता याच्या नंतरच्या केस मध्ये परत काय होणार आहे, जर A plus B ची व्हॅल्यू ग्रेटर दॅन C plus D असेल. ओके, नाउ आय हॅव नॉट कॅल्क्युलेटेड इट, यू ट्राय इट अँड टेल मी हाऊ मेनी टाइम्स दिस लूप विल गेट इटरेट. ओके, सो त्याच्यानंतरच्या केस मध्ये काय होईल, मग लक्षात येत आहे सगळ्यांना हे? आताच्या केस मध्ये काय झालंय की तुमची A ची व्हॅल्यू आली आहे 6, B ची व्हॅल्यू 4, C ची व्हॅल्यू 7 आणि D ची व्हॅल्यू तिला आपण काहीच नाही केलं त्यामुळे ती 2 आहे. बरोबर आहे, त्यामुळे नेक्स्ट याच्यामध्ये A प्लस B झालं 10 आणि C प्लस D 9. सो नाउ इट इज एक्झिक्युटेड. नाउ त्याच्यानंतर ॲज द कंडिशन इज ट्रू, सो नेक्स्ट अगेन
मॅम थर्ड केस नाही हे होणार, लूप मध्ये येणार, कारण A इज इक्वल टू 5 येईल आणि C इज इक्वल टू 7. आपली आधीची व्हॅल्यू 7 आणि B 4 म्हणजे 11 होईल आणि B इज इक्वल टू 4 minus 2 2 होईल म्हणजे 5 plus 2 7 आणि इथे ऑलरेडी आपली C व्हॅल्यू इज ग्रेटर दॅन A प्लस B, सो थर्ड केस इज नाही लूप मध्ये जाणार.
येस येस. ओके, सो दॅट मीन्स दिस लूप विल बी एक्झिक्युटेड आणि त्याच्यानंतर म्हणजे त्या या कॅल्क्युलेशन नंतर काय होणार आहे, एंड ऑफ लूप होईल. ओके, ॲज द कंडिशन इज नॉट ट्रू, so there will be end of loop and then next equations that will be executed. That means next statements जे काही असतील ते execute होतील and then there will be end of process. Okay. So that means how many times this loop will be iterated?
2 times.
Yes. Okay. So third time it will be out of end of the loop. Okay. So this is the while loop statement. Okay. Then after that there is a one more type of statement that is used in a sequential statement, that is the next statement. Now what this next statement does, it keeps execution to the next iteration by of an enclosing loop statement. Okay, so that and then it proceeds with the next iteration. Okay, म्हणजे इथे तो काय कर what it will do, it will keep the execution, whatever execution it is doing, it will keep that and then it will go to the next statement. Okay, if the loop label is absent, then next statement applies to the innermost enclosing loop. Okay, so if there is no any loop label that is assigned, then it will go to the innermost enclosing loop, and the syntax for this is next, then loop label, when, and condition. Okay, so that means when it is going to the next statement, that will be decided with this when condition. Okay, so if this condition is true, then it will go to the next statement. Okay, so here this when keyword, that is optional, and it will execute the next statement when this its condition evaluates to the Boolean value true. Okay, so that means when the statement is or the condition is true, then it will get executed. Okay, so this example as shown here, L1 is while A is less than 10 loop. Okay, so this here we have this for L1, it is a while loop which till A is less than 10. Okay, and then loop statements are there. Now in that again there is a nested loop, that is the L2, which is again a while loop. It is up to further range when for the condition B is less than 20. Okay, and then there will be certain statements that may be there, but here we are specifying the one statement, that is the next L1 when A is equal to B. That means it will go to L1 when A is equal to B. So it will execute this statement, okay, while B is less than 20, or it is calculating the values inside this loop, whatever are present, till A is less than 10. But when the condition occurs such that when A is equal to B, it will go to the next statement. So these statements will not get executed, and then there will be end of loop L2 and then end of loop L1. म्हणजेच या केसमध्ये काय होणार आहे, ते एक्झिक्यूट कधीपर्यंत होईल L2 लूप, जोपर्यंत A इक्वल टू B असणार नाही तोपर्यंत. Whenever A equal to B होईल, when this condition will get true, it will go to the next L1. Okay, म्हणजे तो L1 ला loop execute करेल. Okay, so this is the next statement. Now there is a one more statement again that is used in VHDL programming, that is exit statement. Okay, so this exit statement that completes the execution of an enclosing loop statement. Okay, and it continues with the next statement after the exited loop. If this loop label is absent, then the exit statement that applies to the innermost enclosing. Okay, the syntax for this exit statement, that is exit, then loop label. Okay, whatever is the label that we are giving for that loop, and then there will be a when condition. Okay, now again, whenever this condition is true, then this loop, it will enclose that loop and continues to the next statement. Okay, so it will go to the next statement. Again, in this case also, this when is optional, and it will execute the next statement when the condition is is true. Okay. Um, so here we have the example, that is a for. Now here we have used a for loop for a in 0 to 10, then loop exit when x of a that is equal to 0, or and then y of a that is equal to x of a, and end loop. Now, what will happen here? Whenever x of a value that becomes 0. Now there may be a certain equation inside this loop. So as the value of a that is ranging from 0 to 10. So 10 times we are going to iterate this, sorry, 11 times. Now as the value of a that is from 0 to 10, that means it will be 11 times iterated. And when value of x of a that becomes 0, then it will end this loop and then it will come out of the loop. Otherwise, y of a will be equal to x of a. Okay. So now, if we look at the difference between the next and exit statement, then you will find that in a exit statement, it terminates the loop. Okay. So whatever loop is there, it will terminate and then it will come out of that loop and it will execute whatever is the next statement. Okay. So these are the next and exit statements which are used in a VHDL when we are using loop statements. Okay. Now one more statement that is used when we are using certain processes, that is wait statement. Now what is wait statement does? It causes a simulator to suspend execution of a process statement or a subprogram. Okay. So that means it will make simulators to wait for certain time, okay, or depending on the condition, okay, until some conditions are met. The object being waited upon should be signal, okay. So whatever the condition is there, it should be related with the signal. That is the condition when we are using wait statement. And then the syntax for this wait is a wait on. Okay, now here this is the keyword that we can use. Wait on, then signal name that could be used. Okay. So that means if certain signals come, then only next statement could be executed, or we can have the statement like wait until certain boolean expression that is fulfilled, or we can wait for and then time expression, that means for certain time period we can wait. Okay. So these are the different syntax, okay, for wait statement. Now here we have example wait on a comma b. Okay. So that means whenever the signals that a and b that arrive, till we have to wait. Okay. So that means this simulator that will wait or suspend its execution till a or b that arrive. Okay. Then another example, that is wait until x is less than 10. Okay. So that means again this execution will be suspended till x is less than 10. Whenever this condition that becomes fulfilled, that means whenever x becomes greater than 10, then only the next statement that will get executed. Or another example where the time expression is used, that is wait for 10 microseconds. Okay, that means simulator will wait till 10 microseconds and then it will execute the next statement. Or again wait on a comma b until x is less than 10 for 10 microseconds. Now here we can use all these type of syntax in a one statement. So wait on a comma b, that means it will wait for a comma b. Again it will wait for until x is less than 10 and for 10 microseconds. So all these conditions are not fulfilled, then till that the simulator will suspend its execution. Okay. And then another example that we can have is a wait until clock apostrophe event and clock equal to 1. That means here uh, till clock event occurs and clock equal to 1 becomes clock becomes 1, that means at a high level, till simulator will wait, and whenever these conditions occur म्हणजे काय होणार आहे, ज्यावेळेस क्लॉकचे लेवल चेंज होणार आहे, इट बिकम्स 0 to 1. ओके, इफ इट इज रिमेनिंग ॲज 1 देन इट विल नॉट बी कन्सिडर. म्हणजे आधी पण 1 होता आणि आता 1 आहे, तर या कंडिशन मध्ये तो नाही हे करणार आहे. पण ज्यावेळेस तुमची क्लॉकची लेवल चेंज होणार आहे, दॅट ऍट द सेम टाइम जरी ती चेंज होणार असली तरी ती फ्रॉम 0 to 1 जाणार आहे, म्हणजे क्लॉक इक्वल टू 1 होणार आहे. तोपर्यंत काय करेल तर वेट करेल सिम्युलेटर. ओके, आणि त्याच्यानंतरच तो एक्झिक्यूट करेल नेक्स्ट इक्वेशन. दॅट मीन्स इट विल वेट फॉर द रायझिंग एज ऑफ द क्लॉक. ओके, so these are the different examples of wait statement. Now, moving forward, as we have discussed now till now different types of statements that we are using in a sequential modeling, okay, or behavioral modeling. Now, in a behavioral design description, uh, so when we are using subprograms, that time it provides a convenient way of documenting frequently used functions. That means whenever we are using certain functions frequently, if we are using subprogram for that, then that becomes easier to uh, get a program or complete program. So there are two different types of subprograms. One is that we can have a procedure which returns multiple values, and we can have a function that it returns to a single value. Now this subprogram that is composed of sequential statements, just like a process. Uh, now, that means both procedures as well as function, it is just similar to that of the process, where there will be certain sequential statements. Okay. Now this procedure call that invokes procedures to be executed in a process. Now we can call these procedures in a process, and then we can get that executed. Now here, related with that, we can have a return statement. Now what this return statement does, it terminates a subprogram. Whatever subprogram that we have written, it will be terminated after a return statement, and then it will go to the next statement. That means it will go to the process again. So the return statement can only be described within a function or a procedure. It is required in a function body but optional in a procedure body. So whenever we are writing a function, that time it is required that we should have a return statement. But in a procedure, it is optional. That means either we can write it or not. Okay, that means we can have it or not, that return statement, then it is okay. So the statement is syntax for this is return and then expression. Okay, so when we want to return to the process, actual process again, that could be decided with this return statement. So this expression that provides the function's return value. The return statement within a function must have the expression as its return value. But the return statement appeared in a procedure must not have the expression. A function can have more than one return statement, but only one return statement is reached by a given function. Okay, so this is about the return statement. Okay, so now till now we discussed about the sequential statements. Okay, so here sequential statement, that means those statements which will be executed one by one. Okay, in a sequential manner. But as we know that here this sequential statements that are used when a behavioral modeling, that is. Okay, so as we know that
Excuse me,
behavioral,
ma'am.
yes, हॅलो.
मॅम सिक्वेन्शियल स्टेटमेंटची स्लाइड नाही दिसत आहे, कनकरंट स्टेटमेंटची स्लाइड दिसते.
हो ना. Yes, I am telling that only. We are moving to concurrent statements only. We have already discussed
ओके मॅम.
till now.
मी
Yes.
पण तेच म्हणते मॅम, सिक्वेन्शियल झालं.
हा, आपण आतापर्यंत सिक्वेन्शियल स्टेटमेंट डिस्कस केली आहेत आणि आता आपण पुढे जाणार आहोत आणि आपण आता कन्करंट स्टेटमेंटला मूव्ह करणार आहोत. ठीक आहे. So just in today's lecture, I will just discuss about this, and then in the next lecture, we are going to discuss about actual statements. ठीक आहे. आतापर्यंत आपण काय केलं की जिथे सिक्वेन्शियल स्टेटमेंट म्हणजे हे कुठे वापरतो आपण बिहेव्हिअरल मॉडेलिंग मध्ये. पण इफ वी आर युजिंग डेटा फ्लो मॉडेलिंग, in that case we can execute statements parallelly. ओके. तिथे जर आपल्याला डेटा फ्लो असेल, आपल्याला माहिती आहे की काय करायचं आहे, आपला डेटा कसा फ्लो होणार आहे, so in that case we can perform concurrent way, we can use a concurrent way so that these processes that can be executed parallelly. ओके. आणि मग म्हणजे आपल्याला पण VHDL लँग्वेज दॅट इज in that we can use concurrent statements, and so we are going to learn about this concurrent statements. आता concurrent statements परत एकदा मी रिपीट करते. What is it? They are executed in a parallel at the same simulated time. म्हणजे आता समजा मला असं माझ्याकडे दोन स्टेटमेंट्स आहेत की ज्याच्यामध्ये मला एक अँडिंग ऑपरेशन करायचं आहे आणि दुसरं ऑरिंग करायचं आहे. माझे इनपुट सेमच आहेत, ए आणि बी. ओके. हे दोन इनपुट्स आहेत, पण मला एका ठिकाणी म्हणजे माझ्या एका प्रोसेसमध्ये मला अँड ऑपरेशन वापरायचं आहे आणि दुसऱ्या प्रोसेसमध्ये मला ऑर वापरायचं आहे. ओके. सो मी जर आधी अँड वापरलं नंतर ऑर वापरलं तर माझं सिम्युलेशन टाइम काय होणार आहे, वाढेल. बरोबर आहे ना. तर त्याच्यापेक्षा मी सायमल्टेनियसली केलं की मी जर तो अँडिंग ऑपरेशन एका बाजूला केलं आणि ऑरिंग ऑपरेशन दुसऱ्या बाजूला केलं, देन I can reduce simulation time, and so here we can use such a type of statement in a program. Okay. So here concurrent statements that are executed in parallel at the same simulated time. It does not matter on the order they appear in the architecture. So whenever we are we are stating architecture, or whenever we are declaring architecture, at that time it is not mandatory that one should come first and another statement that should come next. Okay. So these concurrent statements, in that ordering of that statement, that is not mandate, that sequence of that is not compulsory. So how to state that? Okay. This concurrent statement pass information through signals, and these are the following concurrent statements that are defined in VHDL. First of all, in this, whenever we are using data flow modeling, in that also we are defining process. Okay. That means it is not the case like की सिक्वेन्शियल मॉडेलिंग मध्ये किंवा बिहेव्हिअरल मॉडेलिंग मध्येच आपण प्रोसेस यूज करतो, तर आपण कंकरंट डेटा फ्लो मॉडेलिंग मध्ये सुद्धा प्रोसेस डिफाईन करतो. आता त्यामुळे मग याच्यामध्ये कंकरंट स्टेटमेंट्स आपण कशी वापरतो, तर वी आर युजिंग प्रोसेस असाइनमेंट स्टेटमेंट, देन कंकरंट सिग्नल असाइनमेंट स्टेटमेंट, त्याच्यानंतर कंडिशनल सिग्नल असाइनमेंट स्टेटमेंट, सिलेक्टेड सिग्नल असाइनमेंट स्टेटमेंट, ब्लॉक स्टेटमेंट, then concurrent procedure call and concurrent assertion statement. Okay. So these are the different types of statements that we are using in a concurrent statement or in a data flow model. Okay. So we are going to discuss about all these statements in the next lecture. Okay. So anybody has
Okay,
doubts
ma'am.
regarding this? Yes. Is there any doubt?
No, ma'am.